let's try another problem which is extremely similar, but perhaps a little more straightforward. So we want to find all values of x such that the square root of x plus 1 divided by the cube root of x plus 1 is equal to the number 4. So before we do anything, it's a good idea just to make sure we understand maybe some potential problem points in this expression, especially the left-hand side. So on the left-hand side, we've got a square root. And if I have a square root, I know what? Well, I know that I can't be taking square roots of negative numbers. Okay, not in the world of real numbers. So we have to have x plus 1. It's got to be positive. So it's got to be bigger than 0. You can take the square root of 0, of course, it's just equal to 0, but if you had that situation, you would end up with a 0 in the denominator, which doesn't make sense. So in this story, x plus 1 is going to be positive, so that might be useful a little bit. So the next thing to do is to take the left-hand side and try to, simplify it using my laws of exponents. So this guy is equal to what? It's equal to, by definition, x plus 1 to the power of half, divided by, of course, x plus 1 to the power third. So now x plus 1 is positive, so I can apply my law of exponents, where I take the difference between the two exponents. So this becomes x plus 1 to the power of half minus a third. So just to reiterate, what we're doing here is the general rule, which is b divided by a divided by b to the power c, is equal to b to the a minus c. Okay, that's what we're using here. So this is a kind of a general property, but you do need to be a bit careful. So for example, if b is negative, then this may not make sense. You could be, for example, taking a negative number to the power of half, which doesn't make any sense. So we're only really confident in this when b is positive. Okay, if b is negative, it does work sometimes. For example, if a or c are kind of positive whole numbers, but if they're not, like in this example, it wouldn't make sense. So that's just something to be aware of. But anyway, we have this now, and a half minus a third is a sixth. So I get x plus 1 to the power sixth. Okay, so putting everything together, what do we have? Well, we're trying to find all the values of x such that this equality holds. So clearly, this is if and only if now. Well, we can replace the left-hand side with x plus 1 to the power sixth. And this has to be equal to 4. So now how can I do this? Well, it's basically saying that the sixth root of x plus 1 has to be equal to 4. So this now is going to be if and only if what? Well, if and only if, well, let's take the sixth power of both sides. So I'm just going to do this incredibly carefully. Now, this is if and only if what? Well, now I can use my law of exponents where I multiply them together. And a sixth times 1, well, 1/6 times 6 is equal to 1. So this becomes x plus 1 on this side. And this becomes what? Well, 4 to the power 6 is 4096, I think. Okay, so the property we're using here is what? Well, we're using the fact that, well, b to the a to the power c is equal to b to the a times c. Okay, that's what we're using. And again, we're assuming b is positive here. Otherwise, we could run into all sorts of problems. But it is by assumption, because x plus 1 has to be positive, otherwise this wouldn't make any sense. And I suppose we're also using the fact that b to the 1 is equal to b, if you want to be really strict about it. So finally, we can conclude what? Well, that's positive, that's all good. This is, of course, if and only if x is equal to 4095. Okay. So 4095. So it's a good example. You've got to really be on top of your laws of exponents to do these types of things. But once you've got a bit of practice, they're all kind of the same.